So I would like to invite for the next paper, which is Integration of Shor's Algorithm and AI in Cybersecurity. I would like to invite Dr. Khurram Iqbal from Hamdard University, and the other author is Engineer Syed Saad from Nazir Hussain University. Please start the presentation.
Assalamu alaikum everyone. My name is Dr. Khurram Iqbal. I'm working. Hello, I'm audible? Okay. Assalamu alaikum. My name is Dr. Khurram Iqbal. Currently I'm working at Hamdard University. And my co-authors, Saad Ali and Saqib Munawwar, they belong to Nazir Hussain University. Okay, now I move forward. I want to talk about integration of Shor's algorithm and AI in cybersecurity threats and countermeasures in Pakistan's post-quantum security era. Actually, I wanted to let you know about my title a little bit about why we are integrating. My focus in this research area, actually, why we are hybriding Shor's algorithm and AI. This is a hybrid system, and this is day by day, cybersecurity threats, increasing, and Shor's algorithm is a quantum algorithm, and quantum algorithm, after 2030, will be implemented. Right now, quantum computing is not common, though. Okay, thank you. Quantum computing right now is not common, though. So after 2030, you see people use it. Right now, it's not common. So why people use quantum computing? Because traditional algorithm is RSA ECC. It's breakable. It's working on factoring. Shor algorithms are mathematical. Solve mathematical problems. Shor algorithms can solve very easily, very quickly. Is this prime factorizing? Why? I'll just tell you. Okay, this is my outline of my presentation. I follow this. I start from integration of Shor's algorithm, AI in cybersecurity, and then references. Anyways, integration of Shor's algorithm, again, integration of Shor's algorithm and AI in cybersecurity. So actually, it is a hybrid. Shor's algorithm, just I said, is a quantum algorithm. Why we are using Shor's algorithm? Because it's a break ECC and RSA algorithm very easily. Okay, I'll show you later. Shor's algorithm threats traditional encryption. Recent traditional encryption, RSA, ECC, Shor's algorithm can break very easily. So quantum computing breaks RSA, ECC. AI enables intelligent threat detection. Actually, Shor's algorithm, through Shor's algorithm, we can find some threats. And why I'm implementing AI? Because we want to know patterns. Again, I collect data from Shor algorithm, and now I want to know pattern through AI, decision tree, SVM, support vector machine. Anyways, support post-quantum cryptography development and a real-time analysis improves cybersecurity. Post-quantum cryptography, it's a quantum key distribution and post-quantum computing. We use and then we can say, actually, quantum computing just not only break the RSA, we can use for good purpose. Break means is negative purpose. Positive sign is we use some standards. NIST from there is engineering ASTM, right? In our field, NIST provide us some standards. BB84, I'll show you later, this is a protocol. So problems statement, what are problems? IoT devices day by day increasing. This is also IoT devices. This is the limitation in IoT devices. This is a calculation. Calculation, what I mean, calculation is cannot solve high calculation. Quantum can solve it. So IoT growth exposes cybersecurity gaps. Devices lack support of strong encryption. This is a problem in IoT devices and your traditional, PCs. Quantum threats challenges classical cryptography. Quantum can break. I said quantum break, RSA and ECC. This is a quantum threat challenge. Right now, we should think about, why we are implementing quantum. RSA, ECC, this traditional cryptography will be obsolete after 2030. We should think about it. We should go on, quantum computing. Although in Pakistan, people are not aware on quantum computing. It's like, Google collapse. It's providing GPU, right? So it's similarly, Chinese and, American companies working on it and providing resources, their GPU. Anyways, a short algorithm break a traditional security, and AI enables quantum resist security and a solution. Urgent need for advanced security measure. Just I said. IoT and cloud accelerator. People saving encryption data on cloud. Hacker will save your encryption data for future work. And then once quantum computing implemented, they can break. And then, threat is active. Resource content limit rapid immigration. We cannot go directly, trading system to, quantum. It's, needs more money, a lot of budgets required. So it takes time, but, our country is a nuclear country. So it's still a nuclear country is not a, to be a nuclear country. It takes a lot of money. Similarly in the quantum, its needs is our requirement. Anyways, this is comparative studies. You see classical and quantum. Classical, RSA, ECC, use public key, and quantum cryptography. Actually, this is a lattice-based, hash-based, multivariate polynomial scheme. What is lattice-based? Lattice-based is working on graph theory. It's a mathematical work. Basically, quantum is working on mathematics. Mathematics is very important right now. Before mathematics nothing. In our university, think mathematics useless. Just it's no core subject. It doesn't count in core subject. But I believe mathematics is very important in engineering and any field. So, anyways, second depends on classical channel security by encryption, authentication, key distribution. So in quantum, we use quantum key distribution. They follow some protocols, BB84. So security assurances like security lies on computational hardness assumption, factoring. Security relies on factoring. Factoring is like prime number. Suppose I give you some number like 15. So what are the prime factors? If you can find two prime factors like GCD, right? And then you multiply, then say again, find your 15 number, like 3 into 5. 3 and 5 is like a prime factor. Shor algorithm can solve. If I give you say like huge number, 500, more than 500, you cannot calculate, even your computer cannot calculate very easily. It takes a lot of time. So quantum can solve very easily and break very easily. So anyways, limited use of AI for anomaly detection in trading system. In quantum, AI enhances quantum algorithm for adopting crypt analysis and intelligent defense system. And traditional IoT enterprise network and cloud system in classical, and quantum expands to IoT devices, autonomous system, and quantum secure cloud infrastructure. We can extend in like this field. So this methodology shows algorithm. See time complexity, log n raised to power 3. It's means showing is solving, has a lot of capabilities to solve very, very quickly. So break RSA, ECC, and then if you have a length of password like ABC, you have n is equal to 3. So how many qubits you need in quantum computing? 2n plus 3. N is equal to 3. 3 multiplied to 6, 6 plus 3, 9. You're increasing n number, then you go more complex. It means in quantum computing, you cannot solve very easily through your tradition. You increase n password, you get length of password, you're increasing, and then more complex. Anyway, quantum computing works. It works on like a superposition. Actually, works on photon polarization. First, quantum computing basically, I don't know you are aware of it, quantum or not. So quantum computing basically is It's like photon polarization. It's a light. You know, light is is the only thing in this universe can travel very fast, right? 3 into 10 to the power 8. So we can transmit data. You know, right now, optical fibers, and then the light passes through optical fiber in the hollow tube. So, photon polarization means like light, through quantum filter, we can, align the photon's direction. It's like in waves, like a crust and truss, 0 and 1. So this showing, combining this 0 and 1, this says superposition. Quantum computing, quantum computing in, along with superposition. What does it mean by superposition? I can elaborate in very easy term. This is like you have a coin, you go in a toss this coin. In the air, you see you have two, like head and tail. This is like a can possible head or tail. So this head or tail is like a superposition. It's like in waves, like 0 and 1. So this is superposition and then entanglement. This what's the relation? Entanglement means like a one cubic changes, other cubic changes. You relate each other. So this is like a this is a quantum algorithm. Basically quantum follows laws of physics, right? So like a lot of physics. So anyways, classical exponential time and quantum is polynomial time, and cryptography definitely obsolete definitely after one day. Just I said. So anyways, methodology. You see, these are points. These are points. Why I write here, because who is interested in this area can follow and do more research work. Even I can tell you, if you are interested in this field, you can use Python like Google Colabs, and then you use this one library, Qiskit library. You work on it and then work as a simulator there. So research design is like qualitative research design you hear, and you use like published data. Definitely do in cyber, let confidential, a lot of things. So you find collected data and from different sources, IEEE, such as IEEE, Springer, Elsevier journals, and else. This is a comparison between traditional and quantum algorithm. ECC, RSA shows. You see these all algorithms. See ECC is like time complexity root n, and RSA 2 raised to power n over 3. And Shor's algorithm time complexity is log n raised to power 3. It's a more faster. So Shor's algorithm definitely breaks RSA. Shor's algorithm not it's started from 2016, not now. Actually, we are not aware. It's 10 years already gone. This is now maturing right now. So these are as before, as I said before, quantum key distribution. BB84. This is a protocol. If you want to communicate, you need to follow some standards. Protocols, you need to follow protocols. The BB84, BB is like the two scientist name. 84 is like 1984 because this protocol is established in 1984. So what is here? Protocol in photon polarization in code bits. So eavesdropping, securities, distance limitations, trust nodes. You want a wider. Definitely, you need some trust nodes. In graph theory, about nodes and edges. You want to increase the nodes, definitely you need more trusted, networks. Post-pornography, we have to follow standards. What are standards? Yes. Pakistan is supposed to. My suggestions, like who is working on security work. So for Pakistan, we need to follow these standards. We should not. We should go upgrade. We should upgrade. We should not rely on traditional. Thanks. So this is the lattice-based algorithm is Crystal Kyber. This is key encapsulation. What does it mean, key encapsulation or cryptography? I mean, not cryptography. What does it mean, key encapsulation? Key encapsulation is like this is your data and encapsulated. What it means is a pack with your data is packed with something. This is one encapsulation and one encryption. Encryption means suppose you have a password ABC. This is one encryption code before. Like I said, I write encryption code is 1. It's not visible to you. It's like ABC is I encrypt 1 means BCD. This is our encryption. If you use a dark web, you see like a hashtag, like hexadecimal letters, So lattice-based, we use crystal dilithium. This is a signature-based, hash-based Sphinx, minimal assumptions, code-based scheme under evolution. It's standardized completion 2024 and 25. It's mature right now, quantum computing. We should figure out how to implement in Pakistan this quantum, and we should collaborate with Chinese, universities. So research key finding is like polynomial type crypto analysis threat, post-quantum cryptography. We should follow NACE. Actually, my motive is to hybrid quantum and AI. This will be more powerful. Quantum helps you to calculate, and AI find you pattern in knowledge detection. So AI ML. I guess you are aware with some machine learning algorithms like decision tree, random forest, and SVM. This SVM is used for classification or decision trees like yes or no, 0, 1, 0, 1, like that. So actually we can implement it. A quantum system is different, AI system is different. You collect data from quantum and then put in machine learning algorithms. So IT cloud long-term exposure windows requires urgent migration, right? So this is my proposed solution towards Pakistan. Use hybrid system, and then definitely you enhance security, combines QKD and post-quantum computing methods, protect against classical quantum threats, BB84 use BB84 protocol, enables secure key exchange, star topology. In a star topology, each network is independent with other and follow one like a router. Everyone talk with router, not each other, which is a highly secure, So there's a future work, establish national PQC roadmap immediately, cover government defense critical sectors, align with NIST standardized timeline, ensure cryptographic agility across system, develop strong regulatory security framework, integrate AI-driven threat reduction. So this is a conclusion, and this references. Any questions? Thank you.
Thank you, Dr. Khurram. That was an interesting presentation related to quantum computing and its benefits on cybersecurity. The question-answer sessions will be handled in the end of the session. Thank you.